What is up, YouTube? Welcome back to another episode on Code with Annie. And in this particular episode, we're going to take a look at the most commonly asked multi-threading problem, which is the producer-consumer problem. All right. So before we dive into this video, I'm going to divide this video into two videos actually. So this video will be focusing only on the problem statement and the code. The next video will speak on the execution part. All right. So that is for the ease of the length of video as well and for your understanding too. So without further ado, let's get started. Now, the producer-consumer problem is basically a very simple problem if I tell you in layman words, right? So let's say I go to a bakery and I try to purchase some chocolates, for example. Now, there is a basket in which the shopkeeper will place the chocolates and there I'll pick it up and start eating. Now, the condition here is only when the basket is full. That is, let's say if there are 5 chocolates in the basket is full. It's a small basket, for instance. Now, only when he has done placing the 5 chocolates in the basket, I can start consuming chocolates one by one. Alright. So when he places the chocolate in the basket, I may not try and take it immediately. I will wait till he has placed all the chocolates in the basket and the basket is full. Then it will be my turn to start picking and eating it. And he will not try to put more chocolates as I'm taking them out. So once I've completely taken out all 5 and eaten them, then I'll notify him and he will start putting more chocolates into the basket. On the side note, it will cause health issues if we eat that many chocolates, so don't do that in real time, but just for the sake of this problem, just kidding. So yeah, you have this particular issue, right? So this is what is called as producer-consumer problem in the world of multi-threading, wherein consider myself and the shopkeeper as 2 threads and the chocolates is the resource that we are trying to consume. So one thread will be trying to put the chocolates in the basket while the other thread will wait till the basket is full and then we'll start consuming the chocolates, and once the basket is empty, the first thread which was putting the chocolates will get back to the job of putting some more chocolates in the basket, right? So let's try to code this, okay, and see how it looks like. So what I'm trying to say is, let's say we have a class, okay, and I'm going to call it as the producer consumer class, okay. For the lack of proper name, I'm just giving a simple name for it just to highlight the problem in hand. That is the producer consumer problem. So I'm going to call the class as producer consumer, and what I'm going to do here is I'm going to try to write 2 methods here. One is produce, which is basically to put the chocolates, and consume, which is to consume the chocolates as it is. So instead of chocolates here, I'm going to use a list of integers, okay. I'm going to say list of integer space, okay, we have to import integer. Let's import it. A list is equal to new array list of integers. All right. And I also need a maximum capacity, right? I need the capacity of the basket, like I mentioned, 5 chocolates it can hold. Same way, I'll create this list which can hold 5 integers. I mean, maximum capacity of the list is 5. Let me enforce that through a private final int max capacity is equal to 5. Do note that always try to use the entire caps with underscore or entire caps like naming convention whenever you have something final and constant, right? So try to use these kind of variables, because don't use the not something like this, instead use this. So that is a common good practice, just letting you know on the side. And this can also be private. All right, reason it is final is because the 5 is not going to change, and the same way I'm not going to modify the list, so let me keep this also final, so we can keep it here. And then we have private int value equal to 0. So what this value indicates is basically the starting point for my max capacity. Basically not max capacity, this is the first item that will be put into the list, which is value 0, then value 1, value 2, value 3, so on till value 4. Well, let me keep it very simple, let me keep it 1. So 1, 2, 3, 4 and 5. Once it reaches 5, which is the max capacity, we will stop putting more items into the list. So let's code that. So let's create the method public void produce, and all this method is going to do is push some elements to a list. So simple, right? But here we'll use a keyword called synchronized of this, and we'll do our operations within this one. The significance of synchronized is whatever is being executed within the synchronized is called as a critical section, meaning any thread that tries to invoke this produce, right, if it sees the synchronized block and if it goes and executes the logic here, no other thread can directly go and take over this particular block. Okay, what I mean to say is when one thread is executing the synchronized block, the other thread has to wait before it can actually get a hold of this. This is called as a lock state. So something inside this will be executed by only one thread at a time. Okay, just keep this in mind. Now synchronized of this, and here we will have the logic to put the elements into the list. So before that, I will just check if a list dot size, oh 1 minute, size, right? Yeah, not equal to max capacity. That is, if the list is not full to its brim, we can do a list dot add value, increment the value, okay, and then I'm just going to print out added value or produced value, and I'm just going to put the value values value basically, which is 1 initially, then it becomes 2. So I'll just put that actually here because I am doing an incrementation. Value plus plus would basically say value is equal to value plus 1. So this is something that you've already come across in programming, incrementing the value. And then I'm going to say thread dot sleep. The reason I'm doing this is because I want the code to pause and go slowly, because if it goes very fast, all these lines will be printed back to back and you will not even notice what's happening. I will not even be able to show it. So I'm just slowing down the program by introducing a sleep. Now this is a timed waiting. Okay, thread dot sleep of 1000 milliseconds basically means for 1 second pause the program. Then I'm going to say produce, because I will keep calling produce until I reach max capacity. So this is a recursion call. So if this calls produce, it will go back, it will invoke this method, it will go into the synchronized block, check the size, not max capacity yet, then add to the list. So at some point it will anyway match the value of 5 and it will come out of this if. And here what we will do is we will say wait, because now we are invoking the wait on the object. What is the object? The object here is, when I say synchronize of this refers to the instance of producer consumer, and like I mentioned in my previous video, you have to always invoke wait and notify on the object. Okay, so the thread that accesses produce method, when it sees wait, which is the wait on the producer consumer object, it will go into a waiting state. Okay, so this completes our produce method. Let's go and write the consumes method. I'm just going to copy this and just change a few things here. So I'm just going to say consume, same thing, but here now I'm not going to check for max capacity. I'm going to say if a list, not of a list dot is empty, meaning until my list is not empty, keep removing elements from the list. So I'm going to say int removed element, or int removed for simplicity's sake. I'm going to say remove first. So remove first does not rely on the index, it just removes the first element on the list, whatever it is, and it just takes it out of the list. So in case I put 1, 2, 3, it will remove 1 first, and that will be the value of removed. I'm just going to print the value of removed here, and I don't have to increment anything, I'm just consuming it, so nothing has to be added. I'll again sleep so that I can show you slowly. I'll slow down the execution of this method as well, then call consume. Again, I'll keep consuming as long as the list completely becomes empty. So once it reaches the empty point, this condition will fail, and here we'll come and say notify. Remember, I said that once a thread goes into the wait state, some other thread which is executing this critical section, which is on the same object, notice that this is referring to the instance of producer consumer, and this is the object on which both the threads are manipulating, right? Or both the threads are operating on. So this thread has gone into wait because of this object. Therefore, this particular thread which is going to invoke the consume method will notify, and once it calls this notify, the sleeping thread will start getting activated and will try to call produce again. It will go and check again. Okay, now is the list size is in max capacity. It would have already become 0 because this guy would have consumed everything. So he will start adding more elements, and again he will go into wait state. So this process will keep happening continuously between the producer and consumer, right? So I just showed you two methods. I didn't show the threads which will be operating it. So let's create those as well. Let's go to the main class and let's first create the producer consumer instance. Oh, sorry, it's the comment section here. Apologies for that. Let me write it here. Producer consumer space, producer consumer equal to new producer consumer. All right. Okay, it's here. Some gimmick happened, sorry. Now what we'll do is, let's create two threads. Thread space t1 is equal to new thread of new runnable. I need to give a task to this particular thread, so I'm just dynamically creating a new runnable. This is called as anonymous creation. It can even be simplified with a lambda. I'll show you that in a few seconds. So I'm just saying new runnable and just overriding the run method for the thread. So what I'm saying is, let's execute something here. That is going to be producer consumer dot produce. This is the producer thread t1. Okay, and it is saying put it with a try catch, because obviously there is a sleep within the produce, right? There is a wait and a sleep happening here. So these are timed and untimed waiting. So this is timed waiting, this is untimed waiting. Therefore, whenever the thread goes into a wait state, there is a possibility of getting interrupted, and it will throw the interrupted exception. As I mentioned already in the previous video, it's a checked exception. Therefore, you must have a way to handle that. That's the reason why it's enforcing us to put a try catch and handle the exception. You can throw it here, but anyway, that's the default implementation. We're going to leave it just like that. I hope no one interrupts the thread for the sake of this explanation. Let's go ahead and say thread space t2 equal to new thread, and this is also going to be new runnable. And here I'm going to have producer consumer dot consume. Same thing here as well. It will ask you to surround with try catch, because interrupted exception can be thrown, as here also we are having a timed waiting. All right, so we have two threads, t1 and t2, and if we say t1 start, t2 start, it should automatically start both the threads, and producer and consumer will go back to back and execute. So t1 start, t2 start will call both produce and consume back to back, and once t1 enters this particular synchronized block, it will execute the entire thing, which is produced till max capacity 5, and then go into the wait state. Then consumer thread, which is t2, is going to call consume. That is going to start consuming the elements of the list, and once it is done consuming completely, list becomes empty, it calls notify, which will again start the thread t1 to start the produce operation. So this is the interaction, and this will be live run in the next video, so stay tuned for that. If you like this video, hit the like button, subscribe to Code with Ani if you haven't already. You can go through this video again to understand in more detail if you feel that this was a little fast, but I think we have already reached the 10-minute mark. So I'll see you guys in the next one with the execution of this one. Bye-bye.